MCs of Swift, it's Prof G, and to quote that great poet Coolio, in this lesson we're going to slide, slippity slide as we head out on a fantastic voyage to learn how to use the slider control in Swift. And along the way we'll learn 3 ways to format decimal values. Let's cruise on into the big learning. If you're new here, welcome. You might want to check out the course playlist to see how we got here. Friends, in the prior lesson, we learned about two-way bindings in Swift as we worked through a cornucopia of controls. Well, in this lesson, we're going to continue the binding buffet as we add the slider control in Swift. Using the slider control, we grab an area called the thumb and pull it along a line called a track to set a value between a specified minimum and maximum. So let's build one. We'll add a spacer below the stepper, then we'll enter slider. We've got lots of options here in code completion. First, let's work with the most basic version. So we'll select the one with the value and the in parameter. The other parameters here are optional, gray italics. Now, code completion says it selects a value from a given range. The value type is binding, and it says that it's binary floating point. Now, floating point, when you hear about floating point, think about a decimal point. It wants a decimal value in here. It will accept a double type. But note, an int is not a value with decimal points, so an int won't work in here, and we'll see that. Now, we also see that we have, once again, a closed range. This wants binary floating point as well, meaning decimals, but as long as our value is set to a decimal like a double, then Swift will assume that the range are double values too. So let's get in on this action. We'll press return to accept these values, and it wants a binding value in here, so we need to create that. Let's scroll up to the top, and we'll write at state private var slider value equals, and I'll initially set this to 50 without the decimal point, so we know via implicit type setting here, when we initialize a value to a number without a decimal point, Swift will assume it's an int, not a double. No decimals here, so if we go back down to our slider and we enter our value as $slider value, Xcode gets grumpy, and the angry red circle says initializer requires that int conforms to binding floating point. Again, consider point to mean decimal point. So because we initialized slider value to a value without a decimal point, Swift considers that an int, and for sliders, that's no good. But you, Swifty Smarty, know the fix. It's super easy. We'll just zoom back up to the top, and we'll add a .0 after 50. Now Swift considers the slider value to be a decimal. It will initialize this as a double, and we'll head back down to our slider. We see that error goes away. Now we need a closed range. This also wants floating point values in here, but since the slider value is already initialized as a double, we added a decimal point here. We can just enter our range as 0.100, and it will consider these to be doubles as well. And look at that, we get an ultra groovy slider with a track and a thumb. The thumb is right in the middle. That's because we initialized our slider value at 50 and our range is 0 to 100. Nice. And so we can see the results of our slippity slide. Let's add a text view below this, and in quotes we'll say slider value : string interp passing in slider value. But great googly moogly, friends! Look at those decimal points. Way too many. Not a good user interface. How can we get rid of those fractional values? Let us acquire more skill. One way is to simply convert our slider value to an int within our string interp. Once it's an int, we'll drop all decimal points. So if I double-click to highlight the slider value inside the string interp, here's an Xcode pro tip. If I press open paren, Xcode will surround the selection in parentheses. Then I can just go left outside of that first new parenthesis and enter capital I int. This is going to convert whatever's inside there. This is my double value into an int. Then the string interp converts the int into a string, and since it was an int before it was a string, we see no decimals. Righteous! Now here are 2 more techniques. Technique number 1. Let's delete that int slider value and go back to just slider value in the string interp, and we'll use a Swifty technique. We'll say formatted, and select this option where you pass in the format. And the description says it formats this with a format style. What the heck is that? Well, friends, we got to go on a bit of a trip to get where we want to be. Let's press return. Hey, dot notation, what's a format style? Lots of options in here. We want dot number. Press return to enter this, but wait, there's more. Dot notation again. Precision is what we want here. This modifies the format style to use the specified precision. Then it says that it takes a decimal dot format style dot configuration dot precision. It's getting gnarly in here. Press return. Dot notation again. We see an option for fraction length. Seems promising. This says it returns a precision that contains formatted values to a range of allowed digits in the fraction part. Xcode, too nerdy a definition. It should say specify the number of decimal values to use. That's all this does. press return. Let's do that. We'll enter a 1 for 1 decimal point, and look at that, 1 decimal point from our slider. Slippity slide it around. Works great. Now let me show you that second option. This is less Swifty, but it uses what are called standard format strings, sometimes format specifiers or format specifier strings. This is a standard that's used in lots of other programming languages, so knowing this is a good thing. Let's clear out what's inside the string interp, and we'll enter capital S string, and there are lots of ways to set up a string. I'm going to arrow down all the way in here until I find the option with the format parameter. Here it is, format and arguments. So press return here. What are the formats? Dot notation won't help here because this wants a string. What kind of string? Follow my lead. Between double quotes, we'll enter %, dot, 1, lowercase f. This looks terribly unfriendly, but it's a standard code for formatting strings. The % side marks the start of the format string. Dot 1 means format this to 1 decimal point. F means that we're going to be formatting a floating point number. In computing, floating point means the potential for a varying number of decimal points. In Swift, double values are fine here. They have a floating decimal point too. So let's tab over to arguments, and we only have one value to enter here, slider value. That's the variable we're formatting. And we see that this works, friends. But let's change that dot 1 to, how about dot 3? And ding dang decimals. Look at the 3 decimals in the output from our slider. Looking good. And you can even put a 0 in here to drop all the decimal values. But most of the time you use the slider, you're going to want to have no decimals in here. I think converting from double to int is simple and it's easy to remember. So I'm just going to put inside the string interp, capital I int, and between parens, slider value. That converts the decimal value, the double, to an int. The string interp handles converting the int to a string. 3 ways of specifying the number of decimal values in Swift in your skill set. Nice! But there's even more slidery goodness for us to perform. The current slider does not show our ranges as part of the slider. So let's add labels to the ends of the track to improve our user interface. And to do this, we'll delete the standard slider, but don't delete the text view below it. Enter slider again, and this time choose the option with value in label, minimum value label, and maximum value label. You see some other optional values in here that are dim and italicized. Code completion says this displays the provided labels, so let's press return. The value continues to be $slider value, tab to in, that'll stay at 0 triple dot 100, then tab to label. And when we see a parameter value that has something on the left, an arrow, and something on the right, this means that it'll give us a closure. So why don't we press return here, and holy smokes, we've got 3 closures in here. The first one isn't labeled, but we're going to put a comment in here that says accessibility label. This is where we can put in text that will be read by accessibility features in iOS. This is a hugely important topic. It deserves its own lesson, actually several lessons, so we'll get back to this. Goodness on accessibility is coming. But for now, let's tab over to minimum value label, and here's where we put in the left side label. Now we can't just enter 0 and 100 in our 2 labels in here, and we can't even enter the strings for 0 and 100. These closures actually want views inside them. So if we want strings, we should say text and then pass in the string for 0 in the minimum label and text with the string 100 in the maximum label. That's much nicer, but since these are label closures, we can do more. And we've seen something like this with the button that had a label in it. We can add an image, so why don't we do that up top, starting in the minimum value label. We'll say image, selecting the option with system name, and here I'll put in the string speaker.minus, and we get an error. And the error description isn't very newbie friendly, but here's what you need to know. You need to have the same types of views in both of these labels. So up top we have a system image and a text view, but down below we only have a text view. So let's copy that image view from the minimum closure, paste it into the max closure. We'll change the string to speaker.plus, and Swifty Legends, it looks good. Now this looks so good that we can actually pare down our user interface. Why don't we put a percentage character after the string interp in the text view below, and this will allow us to delete our text views in the labels. We can only leave the icons in there, since it's intuitive that a percentage would go from 0 to 100. This looks great. Once again, the learning was vast. We learned about the slider, we added slider labels, we added a view showing slider values, and we learned 3 techniques for removing or altering the number of decimals in floating point values, converting to an int, using formatted number precision fractional length, and using format specifiers, aka format strings. Let me know what you thought of this lesson, and be sure to slide back into the big learning. Hack on!